Hey pre-calculus class, I'm going to show you how to use Google Sheets to do some of these normal probabilities questions that we're seeing in the homework. Alright, so on this problem, I'm trying to find the probability in a normal distribution, a z-score, the standard normal distribution. The z-scores will be below 0.47. So what I'm going to do here, and the first cell, it doesn't matter where you put it, I'm going to do equals, and I'm going to start writing the word normal. And when I get to the M, I'm going to find this one that says norm.dist, normal distribution function. So when I click that, click the little question mark so you can see the information of what goes in here. It wants a value, the mean, the standard deviation, and something called cumulative. So when you see these problems, this is going to be your value, the z-score that they give you. So 0.47, and then comma the mean, because it's the standard normal distribution, the mean is 0, the standard deviation is 1. It's telling me this now. It's not going to tell me this as I go through the homework set and go deeper and deeper into these problems. So you're going to need to know for standard normal the mean is 0, the standard deviation is 1. Now cumulative, we want cumulative. Cumulative means, do you want this area, which is the blue shaded region, which is exactly what we're doing, find the area. So cumulative, a 1 for true means I do want the area. A 0 for false means I want the height. Like how high up is this? For this, the way when we make a bell curve, the whole entire area under the curve has to be equal to 1, from negative infinity to infinity. So this little bubble has to have a certain height based on how spread out it is. And so based on the mean and standard deviation, the height right here at this number would need to be 0.3572 roughly. But we don't care about that. We want area. So we need to make sure that this is a 1. So just know for all of these where you're finding probability, all of these that we're going to do, we're never going to put anything but 1 there for cumulative, which means true. You can also write the word true, right? But we're just going to put the number 1, and that means true for Google Sheets and Excel. So there's the number that I want. I'm going to make this a little bigger so we can see it. And these get rounded to 4 decimal places, 0, 8 to 4 places. Now that is the same, or roughly the same, sometimes because of the rounding, because Google Sheets and Excel are going to give you a lot more decimal places than these tables will. So I just want you to see the table. Page 1 of the tables are for negative z-scores, and this is a positive z-score. So I just want you to see if I click that, these are negative z-scores. So all these numbers over here on the left are negative. Right? This is a positive z-score, 0.47, so I would need page 2. And I'm looking for this in 2 pieces, so 0.4 along the left side and 7 up on the top, or 0.7 on the top. So there's 0.7. So if I scroll down until I see 0.4 where it meets this number, there's 0.6808. So where those two meet, the 7 and the 0.4, that is the probability that you are below 0.47. And that picture tries to kind of show you, match up what you're seeing right here. So that's how you would use that. Okay, now above, if it's to the right and not to the left, what we have to do is 1 minus the area to the left. So again, this function, normal.dist, will give me percentage to the left of a number, or area to the left of a number. But if I want the area to the right, I use the fact that the whole area is 1. So 1 minus this area will leave me with the blue area. So down here, I'm going to write 1 equals 1 minus normal.dist. Right, x, there's my number, negative 0.82, comma, the mean is 0, standard deviation is 1, and again, I always pick cumulative. Right, so there is my area to the right of a number. All right, now if I want to make myself a little note, 1 minus norm.dist for, that's right, that's perfect, that's great, as long as you are practicing doing this on a blank sheet, because again, final exam time, you're not going to have access to any sheets you build, so you'll just need to make sure that you are practicing it and can reproduce it on your own on a blank sheet by the time the final exam time gets here. All right, finally, this last example, this is the area between two numbers. So what I'm going to do here is I'm going to do it in two pieces, 3 pieces technically. I'm going to find the area to the left of the upper number, the 1.25, the area to the left of the lower number, negative 0.92, and then I subtract those 2 areas. So the area below this all the way down minus the area from that number all the way down is the area between the 2. So this is, I'm just going to label it area 1.25. That's going to be equal norm.dist. The value is 1.25, the upper number, mean 0, standard deviation 1, and cumulative again, always yes. So there's that number that's below that one. Now, the area below the lower number is norm.dist, negative 0.92. The mean is 0, the standard deviation is 1, always 1 for cumulative. So there's the area below that number. So if I take this area away from this, then I'm left with the blue area between the 2. So I'll just label it area between equals, and I click this number minus, and there's my area between. So I already did this problem before, 0.7156 to 4 places, 0.1556, so it would round to that. Again, TI-80, 384 is probably better for this stuff, but Google Sheets is very accurate, very efficient if you can get to the point of understanding how to do it. So to the left, these types of problems, this is exactly what normal.dist is designed to do, give you the area below a number. So there's no manipulation I need to do. That is the probability, that is the area. For to the right, I need to do 1 minus to get the number. So when I see a problem like that, I have to understand that that's what I need to do. 1 minus the area to the left of the number is the area to the right of the number. And then for between, area to the left of the upper number, area to the left of the lower number, and subtract those 2 areas. And you've got the area between the 2.